Hi friends, this is Anil here and welcome to my YouTube channel Shreyas Data Insights. So in this session we'll understand Hadoop cluster configuration, what are the variable possible ways, okay, and what are the available distributions, and what is the metrics that you need to consider if you want to install Hadoop. Okay, so let us start. So coming to the generation 1, we are having a specific components, right? Some of them are working as master demands or master services. At the same time, some of them are working as slave demands or the worker nodes. So we'll write here. For example, you are having a name node, okay, data node, and of course a secondary name node. This is not master, even not a slave, also just a checkpoint node which is doing some housekeeping jobs. So these are all related with our HDFS, Hadoop Distributed File System. Okay, right. Now whereas coming to the resource management and processing, which is going to be taken care by job tracker and task tracker in generation 1, right? So let me write here job tracker and task tracker. So these are related with map reduce framework here, so which really takes care of processing and resource management. So this I am referring to generation 1. Okay, so in generation 2, this remains same. Let me write here, thus I am representing as generation 1. Fine. Now this is about generation 2 here. Fine. Okay, so this common here, name node, data node, and this is optional. Secondary name is purely optional, and here you can have high availability, nothing but you can have more than one name node, so provides hot standby here. So you can have name node 1 and name node 2 also. Okay, one is an active and one is an passive state. So here I'm talking a scenario called high availability, so where you are having multiple name nodes. Got it? Name node 2. So this is an active state and this is in passive state. Fine. Right, now there is no problem with the data node, it remains as usual. And coming to this, it's purely optional. Okay, and of course you can implement the federation concept also, that's fine. Multiple namespace and multiple name nodes you can federate on a common data storage. And this job tracker and task tracker are now limited only with the processing. Okay, only limited with processing here. Processing. Okay, and now who will take care of this resource management and I mean to say the cluster management and everything? That will be taken care by the other services, right? So resource manager, so this is the master which is associated with node managers, right? So this we are referring as here, right? So these are the different services, and these are really needed to work on. So coming to this processing, so here you can have MR, nothing but the map reduce as a default, or you can have Tej, or you can have a Spark framework or a slider. It purely depends. Okay, it purely depends how you're going to process, but this remains same here: storage, HDFS, and resource management, or you can say the cluster management, which will be taken care by the earn here. So processing, it depends which framework that you would like to use, whether with a traditional map reduce framework you would like to use, or Tej, or a slider, or a Spark. It purely depends here. Now, so once we are ready with this, now how we can plan our cluster? Okay, so for that we are having different modes like local mode, pseudo distributed mode, and fully distributed mode. So fully distributed mode is the one which is used in real-time environment. So how it really looks like. So let me drop some picture here. So this is my name node, okay, and I will write like this. This is my active name node, and of course this is my standby name node, okay, and I can have this resource manager, okay. So these are all my master services, and I do have multiple data nodes here, okay, multiple data nodes here like this. So this is my data node 1, and this is my data node 2, and this is my data node 3, of course, okay. This is my data node 3. That's fine. So of course optionally you can have secondary name node as well, okay. Let me write that also, but this is purely optional. This is secondary name node. I'm talking about high availability scenario. In that, secondary name node is purely optional. So let me put here, but this is a common thing. So this is your Hadoop cluster in real time. So master services are running separately, and of course slave services are running separately. So on top of this data nodes only, you are having your node managers here, okay. You can have your node managers. So node manager 1, node manager 2, like the way you can have a number of node managers. Fine, that's good. Okay, of course these guys are controlling, and anyway we know how these like you know how this name node controls the data nodes, and how the communication takes place between resource managers to data nodes, and to the node managers and all. We discussed, right, everything. So I'm not going with the same stuff now. So this is something like fully distributed mode, because all of my services are running separately here. Name node is running on one thing, and standby name node is running on separate server. Resource manager is running on separate node or a machine kind of thing here, and these are all my data nodes. So this is a fully distributed model. How the real time follows, okay. And these servers or these services can be maintained locally or in cloud also, okay. I'm repeating once again here what you can do. So these services can be maintained locally, or these can be maintained in cloud also. So for example, if you want to maintain the same thing in cloud, what you can do is you can go with either Amazon Web Service, nothing but AWS, okay. So you can go with, if you're talking about cloud, either you can go with Amazon Web Services, or you can go with Google Cloud Platform, nothing but GCP. So you can use the platform, okay. You can plan your cluster, what exactly your RAM that you are looking for, how many processors that you are looking to plan, for example, for your cluster, and what is the disk space, what is the operating system that you are looking for. So all these things can be given, and you can go and work with AWS or GCP also. So what is the advantage of this, okay? If you want to maintain locally all these nodes, all these services, it's really a tough job, right? Because you should have some very good RAM. For example, this guy need a very good RAM, and these guys data nodes, as they are storing a lot of data, they need a lot of disk space, right? So like this, you have to supply all the resources here, like disk space, network, CPU, and RAM, of course. I mean, the processes and everything here. So the resource, now you know the resources are very expensive, right, if you want to maintain them locally. So what you can do is alternatively you can plan the same setup in cloud also, like either using AWS or GCP, Google Cloud Platform. Okay, what you can do is you can create your own machine, local machine. Otherwise you can create a free account also. In AWS the user account valid for 6 months, and in GCP the free account valid for 1 year. My advice is, if you want to install and configure, and if you want to work on this cloud based thing, you just go with a GCP, because you will get 1 year subscription free of cost, and creating and maintaining the server is also very easy. Okay, how many nodes you would like to have, and what is the RAM that you are looking for, and what is the amount of disk space that you are looking for. So the maintaining and creating Hadoops, okay, at GCP is very easy. Of course in AWS also you can do, but problem is AWS is providing very limited resources when compared with the GCP. Like the way the free account is valid for 6 months here in AWS, and GCP you are having a 1 year full account here. So my advice is better to go with a GCP account here to build your own thing if you want to maintain your cluster at cloud level. Got it? So this particular configuration is known as what? Fully distributed mode. That's fine. For example, if you want to maintain this locally, how are you going to maintain? So the best choice here is you can go with a virtual machine, a kind of virtual machine, something like VMware. So let me put, this is something like fully distributed mode. Okay, I can say this is a fully distributed mode. Right, fully distributed mode. And if you want to maintain this locally, how are you going to maintain? For example, I'm using some Windows operating system, and Hadoop is good with only Linux distributions like Red Hat, CentOS or Ubuntu. In that time, how you can plan your cluster here? So my advice is to to work locally, better to go with a single node machine instead of going with a multi node machine like this. Okay, if you want to do any hands-on locally, okay, better to go with a single node machine. What do you mean by that single node machine really? So you are running all of your master and slave services locally here itself. So this is your Hadoop cluster. Okay, simple one, single node. You cannot say cluster, it's a single node machine, that's it, where you are having your name node, secondary name node, data node, resource manager, and of course the node manager, and your job tracker and task tracker also running on the same machine. Okay, so this qualifies the pseudo distributed mode. So I'm not at all maintaining any multiple machines here. So all of my master services and of course my slave services are running on a single machine by sharing single Java or JVM, I can say, or a heap size, and everything will be shared here. Got it? So this is the difference between this and this. So this is a fully distributed mode and this is a pseudo distributed mode. Pseudo means what? It's trying to just simulate. Okay, it's just trying to simulate all these services, how they really works in real time. That's the reason we'll be calling this as a pseudo distributed mode. So if you want to build this pseudo distributed mode on your system, how you can build that? Example, already you're having a Windows operating system. Okay, Windows 7 or maybe 10, whatever it may be, you're already running with some Windows machine. So my advice is don't run anything on Windows, because in real time you never get an opportunity to work on Windows machines, right? So if you go through and search how to install Hadoop on top of Windows, you will get some resources or some videos, some materials, but please don't go with that, because you never find any Windows machine on your real time. So my advice is better to go with any Linux distributions like Red Hat, CentOS or Ubuntu. For example, in my scenario, what I did really here, I'm running on Windows machine, and so on top of this, what I did, I installed VMware. Okay, I installed VMware, and here I installed Ubuntu operating system. And on top of this, I just installed Apache, Hadoop libraries. Okay, just I had downloaded everything and I just installed the Hadoop libraries. This is what exactly I did here. Okay, and alternatively, what I can do is you can prepare your own thing. Okay, otherwise you can go with some distributions like MapR. So MapR is one distribution, or you can go with a Cloudera also. So these are all ready made, like they come along with a virtual machine, and I mean to say you'll be having complete image where you're having operating system. Probably they're using CentOS, and on top of that they are using the Cloudera distribution. Similarly, MapR. Earlier we are having one more distribution like Hortonworks. So that Hortonworks is merged with Cloudera. Okay, now Cloudera and Hortonworks are the same here. Got it? So they're providing like one virtual machine kind of thing, so that you can just download that and you can deploy. That's it. So either on Oracle virtual machine or VMware kind of thing here. This is how you can go with this. So you can go with even single node setup also in cloud on AWS or GCP. Okay, so this is very easy actually, I can say that, because maybe your system is running with you're having very less RAM, 4 GB RAM for example you're having, and you are running very old PC, but even then don't need to worry. Okay, if you are really want to use this cloud. So on cloud itself, because they're giving free of resources to you, right? The RAM is provided, and of course the disk space is ready-made available, the operating system, that everything is ready. Only thing is you have to choose a selective distribution, for example like Cloudera or Apache, and you have to install. That's it. Otherwise, either you can go with a Dataproc also. Okay, once you open the GCP, you will get one more option called a Dataproc. So zero installations, absolutely zero installations. Just you have to check, like okay, I'm looking for this much RAM, this much these many CPUs, and this much of disk space, and how many nodes, like a multi-node cluster or a single node cluster. So you have to check all these things, or you have to validate all these parameters. Okay, then you can use the Dataproc. So ready-madely, within 5 to 10 minutes, it makes available to you the Hadoop cluster. So this is something like this setup is only for our hands-on purpose or practical uses, like if you want to test. Okay, and if you want to familiar with the Hadoop systems, how they really behave, so these tips will be useful for you. Okay, if you're running with a very less RAM, and please don't worry, for sake of this Hadoop, no need to go and purchase any new laptops or desktops kind of thing. Happily you can use the cloud. So this is good thing to use really the GCP account. Only thing is you should have some valid Gmail account and along with one credit card. Okay, why credit card means they just validate and they will take 1 rupee from your end, and of course they will return back that 1 rupee also. Just they would like to confirm your age and details and everything. That's it. Immediately your one user account will be created. So directly you can use that Google Cloud account. Otherwise what you can do is you can go with directly using means you have to use the SSH. You can use that directly. Otherwise what you have to do is you have to locally install putty or putty, whatever, it's up to you how you're going to pronounce. So you can install putty, and you have to in putty you have to configure the external IP address of your GCP. Okay, and so that locally you can connect through that server, GCP server, via this particular putty, and you can work with that. It's up to you how you're going to work. So a lot of ways, guys, a lot of ways will be there. It's purely depends how you want to use. So this setup, it's really useful for the guys who are having a very less RAM and locally they cannot deploy any Hadoop machines. So for them, I really advise to go with the GCP. Okay, it's very simple. Have a Gmail account, go with your credit card and create a GCP account. Then you just, if you're having any idea of the installation center, you just start install of your own Hadoop distribution like Apache or Cloudera or whatever it may be, or choose Dataproc. So it will create a ready-made cluster for you, install PuTTY locally on your desktop, and you can connect that particular server with the help of PuTTY, and you can have the fun. That's it. So this is the best way. And coming to the second way, this is something like, if you want to do everything locally, so just install VMware or Ubuntu. Okay, and on top of that, we are just going to have a sudo distributed mode, nothing but all services we are running on a single node or single machine. So my RAM, my processor, my disk space and my network, everything will be used or shared by all these services. That's what exactly going to happen. This is purely for testing purpose, guys. Okay, you cannot test terabytes of data. Okay, it's just only for testing purpose, for our hands-on purpose, to run some business logic on a given data set. Okay, once you did with this, like what you can do along with this Apache Hadoop, you can install Pig, Hive, HBase, Cassandra, MongoDB, even Spark you can install. Okay, Kafka you can install. So everything will be installed and configured, and you can start playing with that. So all of them like open sourced, so no need to pay any single NP to anyone. It really sounds good, right? So happily you can download those libraries and you can start install and you can start working with that. It really creates a fun for you. So no need to pay any single NP to anyone. So here also you are not paying to anyone, right? Because this guy is really amazing. And here also you are not paying anyone, because if you're already having any system and you just Windows 7 or 10, just install VMware or Oracle virtual machine I mean to say. On top of that, you just install Ubuntu OS or CentOS or Red Hat Linux, and on top of that Hadoop, Apache Hadoop libraries, or you can go with a Cloudera or Map or whatever it may be. That's how you're going to do. That's a very simple, right? So it's up to you what distribution you want to use, how you're going to proceed. Okay, so basically my training works and focus on this Apache Hadoop libraries. Okay, in real time, maybe you be getting servers on Cloudera or Mapper or any other customized distributions you can have. But once you are familiar with this Apache Hadoop distributions or libraries, I mean to say, you can work on any work environment. There is no problem at all. Okay, so once you got the familiarity with this Apache Hadoop, you can work with any kind of distributions. There is no problem with that, absolutely at all. Okay, either you can work with a Cloudera or Map or anything, because these guys also uses the core as a Apache Hadoop only. Either you are installing Cloudera or Map. For them also, okay, the core will be Apache Hadoop only. But but just they tailor the product, they customize the product, and they come with some distribution name. That's it. So this is how you can plan either this or this. So this is called a single node machine or a pseudo distributed mode, where on a single machine itself we are deploying all the master and slave services, and this is the fully distributed mode. This qualifies with how it's a real-time environment, I can say this. Right now I would like to show the machine locally here. Just a moment. Here if you look at this, I'm having VMware workstation. Okay, and already I'm having Spark with Scala and all other things also. So let me go with this machine. So Anil test HD. Okay, so just here I have given some 2 GB RAM and 1 processor, so you can edit anytime, it's not a problem. Okay, you can edit this particular machine at any given time, right? So what I did here, I just have approached this procedure VMware, and on top of that I installed Ubuntu, and on top of that Apache Hadoop libraries. So just resume my machine here. Take some time anyway. So here just I'm providing the password. Okay, fine. One second, let me get into the full screen. So this is something like, and of course this is some previous worked out data and all. Okay, but anyway, this is my Ubuntu operating system desktop, what exactly you're viewing at present. Okay, and if you go through this home, I just install the all Hadoop related stuff. So Hadoop 2.3.0 is configured here, and I'm having HBase, Eclipse, of course, Hive, Drill, Apache Ant, and Maven, Woozy, HBase. So everything, like all Hadoop related stuff is there, like big. So I just downloaded and installed everything on this machine. Okay, for students training purpose, right? So this is something like on home, I kept everything and I extracted, and after that I installed. So if you go through this particular folder, you're having Hadoop 2.3.0, you're having bin etc include, and other useful directories also here. So I will be showing one by one here, etc, for example. So here we are having some important files here. So what are the important files here? This Hadoop env.sh, where you're going to set the environment variables, HDFS site.xml, where you are going to keep the parameters for your data node, secondary name node, and name node. Okay, and of course map.site XML for processing purpose, you can set this, right? And nsite XML, resource manager and node manager related configurations you can make here. Okay, so similarly core site.xml, one more important file. You can go with the name node related stuff, the host port number, where you want to go with really. Okay, see, the moment you install Hadoop, okay, you'll be getting these files, but this will be empty files. For example, if you look at, I have configured some parameters here, right? So initially just you are having something like this, you are not at all having anything, you'll be getting some clean kind of thing here. Okay, so here for example I said my host name is localhost and I want to work with a port number called 9000. Okay, and this is the temporary directory. So like this, what exactly I did here, I have given all the configurations and parameters here. So how comes I know what parameters I had to give on particular file? So for this we need to go through the Apache Hadoop documentation. Okay, so once we go through that, there they specify what to configure on a particular file. For example, what has to be configured on the core site.xml, and similarly what has to be configured under this Hadoop env.sh. For example, here only thing you need to set is a Java home path, not more than that. Okay, and sometimes heap size also you need to set. For example, Java 7 is running here, so just I have given this. Okay, So similarly, what you have to set under hdfs.xml. So gedit is the editor here by which I'm opening. Look at here, I'm setting replication as 1. If I'm not setting this parameter, then what happens? By default I'll be having 3 replicants. So similarly, as I discussed in my previous lecture and everything, right, previous sessions, so name node maintains metadata in main memory, at the same time in the disk location also. So where exactly you want to store your name node metadata? So this is the location I have provided. Similar, this is about data node, and this is about the checkpoint node, nothing but the secondary name node. So why I have configured the secondary name node here means because I'm not going with a high availability scenario. I'm going with a single name node. I'm not going with a multiple name nodes. So similarly, you can configure the insight.xml, okay, and map.xml like this. So how comes we know this information? So this information is available with Apache Hadoop documentation. So that they will specify what to configure and what are the important parameters that you need to configure. Okay, so this is about etc Hadoop folder, and similarly we are having sbin. Okay, under this sbin, if you see, we are having some executable shell scripts like stop dfs.sh, okay, start n.sh, stop all.sh. What exactly this really? So these are the executable shell scripts which really useful for us to start and to stop our Hadoop services and Yarn services also. Got it? For example, if you say stop dfs.sh, what happens? This executable shell scripts make sure that all of your HDFS related, nothing but your name node, secondary name node, and data nodes, those services are going to be stopped. Similarly, you are having stop n.sh. If you run this executable shell script, it makes sure that it's going to stop your resource manager and node manager, right? Similarly, you can use this all.sh, start all.sh. So this starts all the services at a time, okay, or you can stop all the services at a time also. Like this, you can start the name node, data node, one by one, and you can start and stop, or you can start at a time and stop at a time. But these you can do locally because the system is purely under our control, so you can test here. But in real-time environment, you don't get any opportunity or access to start any service or stop any service. So it's purely under the control of your Hadoop admin people. That's it. Okay, basically you cannot open the folders like this, and you cannot view even. So that's the reason I'm preferring the learners who started the career initially in this Hadoop environment. Better to go with a local system so that you can see all the files and you can do some experiments, and you can get each and everything of your Hadoop machine. Okay, so anyway, so here we are having some executable shell scripts by which you can start and stop the services. And we are having one more important folder, like a share folder. Here once again Hadoop, and here we are having MapReduce, and Hadoop provides some example jar files here. So this is the one. So this jar file comes with some default programs like word count, sudoku, okay, grab, or any sudo and other pre-example programs. So what we can do is we can run those example program without writing a single line of code, and we can see what do you mean by storing and processing by using Hadoop here. Okay, so this jar file I'll be using in my next session, where I'll be showing, okay, what do you mean by processing, right? So that's all guys for today's session. Please go through this once again, okay, and in my next session, okay, what I am going to show will be completely working on Hadoop commands. Okay, let me write here. So we'll be working fully on commands. I'll be showing some Linux as well as HDFS. And coming to this HDFS, I'll be showing some developer and some admin commands also. and after this I'll be showing store. Okay, what do you mean by store and what do you mean by process, okay, in Hadoop. So for that I'm taking that example jar file that time. So in next session completely we will be working on this. Okay, right. So that's all from my side for today's session. Please like and share your views and subscribe to my channel, and follow this so that it will be really useful to you. Thank you all.